In this next set of slides, we're going to focus on the transfer processes within the water cycle, and basically we'll be answering the question, how does water get from one natural reservoir on Earth to another? And we will be going through most of the processes on this diagram, which is from the United States Geological Survey. You can go to the website shown here on this slide, which is part of the Water Science for Schools site that's hosted by the USGS, and it outlines and describes each of these processes in detail. So we will go through some of the processes, and this graphic is somewhat busy because it has processes like evapotranspiration, but it also has reservoirs, which we learned about in a previous lecture. So like groundwater storage is a reservoir, and then a spring is a source of water. So there's a lot of, and then water storage and ice and snow, again, a reservoir. So let's go through some of these processes, and we won't go through every single one, but we will go through the major ones. So first we'll talk about evaporation, and again, here's the website if you'd like to go through a more detailed description of each process. Evaporation is the way that water gets from land or water on the surface of Earth into the atmosphere. And so in this process, water molecules escape from liquid water as heat is added to the water, and the water vapor then travels up into the atmosphere. Evaporation is a very useful process because it purifies water. So as the water is evaporated into the atmosphere, any contaminants that reside in those water molecules are separated out from the water, and it's just water molecules rising up into the air. If you watch the weather reports on the news, or if you have a weather app that tells you humidity, when it's talking about humidity, it's usually talking about relative humidity. So the term humidity refers to the total amount of water vapor that's in the air at any given time. But relative humidity is what they're usually referring to. Relative humidity describes the percent of water vapor that's in the air compared to the potential amount of water that can be in the air at that temperature. So as you increase temperature, the air can hold on to more water. And so if you're at 98% relative humidity, that means if you increase the humidity just a tiny bit more, the air will be saturated with water, and any additional water vapor that goes into the air will cause condensation and precipitation, which we will talk about next. So basically, you get rain. So anytime you get to 100% relative humidity, the air just can't hold on to any more water vapor, and you will have some precipitation. So let's talk about some more of these atmosphere transfer processes. So we talked about evaporation, but there's some more subtle terms. So transpiration is the release of water vapor from plants. So it's just like evaporation, but instead of the water vapor coming off the surface of a lake or the ocean, for example, it's coming out of plant leaves as they cool themselves off. And so plants take water from the soils, they use it to create sugars, and then they release water vapor from their leaves, which helps to cool them. That's transpiration. A more all-encompassing term is evapotranspiration. That's evaporation of water coming from plants and soil surfaces. And so evapotranspiration is more inclusive. It includes more water coming from surfaces and plants. Condensation is like the opposite. So with condensation, the water vapor is in the atmosphere, and then as the air cools, so for example, as the water vapor travels up farther through the atmosphere, it's going to cool off, and then that water vapor condenses, and that leads to precipitation, which is the next term on this slide. Precipitation then is just condensed water that's falling from the atmosphere. That can include rain, snow, or ice. . 。 . 。 . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Transpiration we talked about on the last slide, but transpiration is a special case because it's looking at plants, and it's kind of a forgotten process in the water cycle. When students learn this in grade school, often they don't learn about transpiration because it can be confusing for some kids. But basically what we have here, so during the growing season, plants are taking water out of the soil. They're extracting it through their roots, and as they pump it up, then they kind of sweat. They put that water vapor into the atmosphere, and that helps cool off the plant. So a way to visualize this, if you take a plant and you wrap a plastic bag around it on a sunny day, you will see a lot of water vapor collecting on that plastic bag, and the water vapor will condense, and then it rains inside the bag. So that's one way you can visualize transpiration if you ever wanted to just see it happening. So basically this is just how plants sweat. This is showing the process on a larger scale. So it's showing how water goes from the water table through plant roots into the atmosphere. So now shifting from atmosphere to surface and groundwater reservoirs, we'll look at some processes associated with these. Infiltration, so the first term on our slide. Infiltration refers to the process where precipitation, so that could be rainfall or snowfall or snow melt, percolates or soaks into the surface of the soil. And so here you can see water flowing over the surface, and some of that is soaking in to the soil underneath that stream bed. Runoff is whenever water is flowing over the land surface, so when it rains a lot, especially we see this here in Arizona, our soils go for long periods of time without rain, and they become kind of like concrete. And then when it does rain, that water initially doesn't infiltrate very well, and so it just runs over the land surface until that concrete gets soft, and then water can infiltrate in. So runoff is any water that's flowing over the land surface. That can just be water flowing over a surface, or it can be water flowing down a stream bed. That would also be runoff. So it's water moving around on the surface of the land. Recharge refers to water that's recharging aquifers or underground sources of water, groundwater. So recharge is any water that infiltrates past the surface soil and plant roots, and that means it's not going to be extracted back up from the plant root and transpired into the atmosphere. So it actually is reaching the water table and an aquifer underneath. This is another process in which water is purified. So we talked about with evaporation, water gets purified as it goes up into the atmosphere. Also, as water is recharged and it goes through and percolates through the soil, it removes biological and chemical contaminants which absorb onto that soil surface, and they're kind of, it's like a sieve, or you can imagine a colander where these particles get stuck in the colander and the water just keeps going through. Okay, and I wanted to mention that there's more than one way we can recharge aquifers. So the natural way is that water runs off over the surface of the land surface, and then it percolates and infiltrates. So it infiltrates into the soil. Some of that water goes past plant roots and gets into the water table and into an aquifer. That's the natural way to recharge an aquifer, but often we sometimes want to recharge aquifers, especially in the desert, and so when we want to store water for later use, we can inject water into the ground, and then that water comes out and gets stored in an aquifer. And then one final way that we can recharge aquifers is from stream beds and river beds or lakes. So any surface water reservoir, that water can go from the lake bed or the stream bed into the water column below and into an aquifer. And one thing I did want to mention with this artificial recharge well So if you live in Phoenix, you go to Arizona, for example, where ASU is located, the water that goes to the wastewater treatment plants, when you flush your toilet or take a shower, all of that water goes to wastewater treatment. That water is cleaned, and then some of it goes to our nuclear power plant where they use it. And then some of that water actually does get recharged into aquifers to help recharge our aquifers for use down the road when we need more water. Okay, so there is a nice quiz graphic that you can use on the USGS website that I mentioned earlier, where it doesn't label all of these processes, and so you can kind of quiz yourself and then go to the website and it'll tell you what A, B, C, and D are on this graphic to help you remember. So I encourage you to do that if you would like to kind of memorize all the different processes in the water cycle.